right. Well, good afternoon, everyone. Welcome to the North Carolina Museum of Natural Sciences. Thanks for coming out. I hope you're excited for our live video call with our paleontology team all the way out in Utah. My name is Chris. I'm the curator for the Daily Planet Theater here in the museum. And what that means is that I get to welcome you and help you have a conversation with our dinosaur experts. Right now, somewhere in the desert, we have two paleontology teams who are actively quarrying and digging up dinosaurs. They are trying to find as much fossil material as they can and help us grow the collection of fossils here at the museum, but also learn more about what life on Earth used to be like millions and millions of years ago. I want to introduce to you the operations manager for our paleontology research lab and the leader of one of our dinosaur digging teams, Lisa Herzog. Hi, Lisa.
Hi.
How are you guys doing? Okay, they're doing great. I'm doing great. How are things out there in Utah?
Oh, things are going really well. Today's our last day in the quarry, and we're trying to finish collecting what bone is still exposed, and then we're going to cover up the quarry and head home. But over the past week and a half, we collected, I think we're on number 266 elements that we've collected from this quarry.
So you've collected 266, like, what are these pieces of fossil? You don't know what they are, maybe, or just things you know are fossils?
266 individual elements from a skeleton of a dinosaur called Falcarius utahensis. And that particular dinosaur, this is a mass death site for that species. And so in the quarry, it's all the same species, and there's just lots and lots of bones all mixed and jumbled up. So we didn't find a whole skeleton, but we're going to piece it together with the parts we found. We found lots and lots of claws. We have lots of toe bones and leg bones. And once we get it all sorted out back at the museum, we'll figure out how much of a skeleton we have and how many different individuals we can make out of what we have.
So out there finding all of these different pieces, claws and bits of bone, how long have you been in the field? How long has it taken to find all of these things?
We've been here about 2 weeks. About 2 weeks for us we had to open the quarry. It took us 2 days to pick through the top layer that didn't have any bone in it. And then we got down to the layer where the bone is, and so we've had about a week and a half of just purely pulling out bones that are all right on top of each other.
Are you sure that they're all this one kind of dinosaur? How do you know they're all Falcarius?
We can tell by looking at the structure of the bones. So this quarry has been here for 15 years, I think, or more. There's been a hiatus of digging in this quarry for a couple years, and so it's been researched, it's been published on, and we know what the bones are supposed to look like, and they all match.
Sounds cool. So I was thinking about this because you and I chatted last week. We were talking about dinosaurs too. But I was thinking, why Falcarius? What is it about this dinosaur that made you want to send your teams out to collect from this specific site, this specific type of dinosaur?
This specific site is interesting and unusual because we don't normally find fossil sites with so many individuals all in one area. When this site was first discovered, I can't remember how long ago it was. It was interesting because Falcarius was an unknown species at the time. And so the initial research was done and the animal was named, but as the quarry's been getting worked for subsequent years, it turned out that it's a mass death site. And so you get there's different ages of dinosaurs in here, so we can see a growth series. We can kind of learn how this particular animal grew as it got older. So there's baby parts and juveniles, subadults, like teenager type dinosaurs, and adults and everything. And we can compare the bones and see what parts of their body may have changed while they grew. And it's really unusual to find this kind of a site.
So when was this particular type of dinosaur first described then? How long ago?
I think it was 2005, maybe. It was described by Lindsay Zano, the head of paleontology at the North Carolina Museum. It was the project she did her PhD thesis on, so she knows this dinosaur really well and discovered a lot of new things about it, and wants to keep studying it because there's so many more bones to explore and find out what new things we might uncover about it and its lifestyle.
So this site and this dinosaur are both pretty unusual then in terms of what you can learn about it.
Yeah, definitely. I think it's the only quarry, it's the only spot that Falcarius has ever been found also.
Is there a lot more there? If it's been quarried before and then your team pulled out over 250 more fossils from the site, is there a lot more there, or have you found it all?
There's definitely a lot more here. I mean, we're going to have to cap some of the stuff that we can't get out on this trip, and we'll have to come back and keep collecting more of it because it keeps going. The more we dig, the more we uncover. I don't know if you can see as far behind me, but we're kind of on a little knob, and we know that there's bone coming out on the other side of this knob where I'm at. So we're on the east side of it, or the south side of the knob, and then if you keep going all the way, this bone bed goes all the way, and the bone's eroding out on the other side. So we know that we could just take this whole hill down and find bone all the way across it.
Wow, that's incredible. So if you're here with me in Raleigh, here in the Daily Planet Theater, or if you happen to be watching live online on Facebook or YouTube, you can ask questions for Lisa. So if you have questions, you'll actually come up here with me. That way, the only way that she can hear you is for us to use the microphone. So if you have a question, you can raise your hand, and then you can come and join me for your questions. Yeah, come on up. So you have to tell us your name, and she's over there.
Hello.
Hi there.
Hi. I was just wondering if you were able to attribute what the mass death is due to, if there was one particular incident, or if that's where they just came to die.
Aside from paleontologists working the site, there also have been geologists looking at the sediments, and there's evidence that there was a drought here. And this was kind of like a spring-fed water source that may have dried up or may have poisoned these animals. I'm not sure, because sometimes springs are kind of polluted by groundwater. And so it's kind of postulated that they came here to get water and then died because of a drought, or there wasn't enough food or something like that. And we've seen in the bones as well. You can look at the bones and see if they had a lot of disease in their bones, like what the structure is, if they had any abnormalities. And it seems like there's a lot of abnormalities in the bones that we're pulling out too.
So you think maybe there was a water source and just dozens and dozens of these creatures swarmed to it but found it toxic, or something else catastrophic happened?
Yeah, it was a drying out. It was a desert, and perhaps the water source dried out and they all died. I don't know if they all died at the same time or if it was periodic, or, it's hard to tell. But there definitely was a spring here. You can tell by the sedimentary structures that there was a spring here.
And this wasn't caused by a meteor impact, right?
No.
Okay. This wasn't all the dinosaurs dying at once.
This was way before all the dinosaurs died. This was the meteor impact was about 65 million years ago, and this site is from 125 million years ago. So it's a much earlier. Yeah, it's a much earlier dinosaur species. It's a really early therizinosaur, which is a theropod dinosaur. And they didn't die out from a meteorite.
So this is like a small carnivore dino.
Yeah, one of the interesting things about this animal is that its tooth structure shows evidence of it transitioning from a carnivorous diet to a plant-eating diet. The teeth have serrations on them, like T-Rex. I don't know if any of you guys are familiar with T-Rex's big, sharp teeth with little bumps along the side, but they're also scoop-shaped, which is indicative of a plant-eating diet, and so they're kind of a mixture of both, which shows that maybe they were transitioning and kind of adapting to their environment that may have been changing at the time.
Oh, so Falcarius is also like an interesting link between carnivore and plant-eating dinosaurs in time?
Yeah, it shows that animals over time can evolve different eating habits. You know, you can go from a strictly carnivorous diet to a plant-eating diet. And then there's a transitional period in between there, obviously.
Cool, cool. Questions from the audience? If you're down here on the first floor with me, you can just, raise your hand. I'll bring you up on stage. You can ask any questions actually that you have about paleontology, dinosaurs, the work that they're doing in the field right now, which you can see some of where they're quarrying back there. For the folks that I see on the second and the third floors, you can ask questions too. You just have to yell at me over the balcony with your questions, and then I'll use a microphone to talk to Lisa. So I'm looking, if you have questions, you can yell at me right now. Okay, I'm going to come down here to the first floor.
Oh, hi.
Hi.
I'm Jim. What would cause a mass fossilization in this one spot versus a lot of other spots the dinosaur might have lived in? And is it possible, do you see signs that they might have been omnivores?
Yeah, there's a signs that they were omnivores. And part of the fossilization process is the bones turn to rock. And a lot of times in order for that to happen, you need to have minerals infiltrating those bones. And that happens usually when there's a water source around. And so if this was a water source that was kind of drying up or perhaps poisoning them because it was a spring and it had the wrong kinds of minerals in it, it would be a good place for, if they all died in the same place, it would be a good place for them all to also become fossilized. So we can postulate that most animals that have died throughout history have not become fossils. And then we question why they become fossils and preserve in the rock record. And it has to do with the process of the bone becoming rock and whether or not there's minerals and water present for that to happen.
So in the process of all of these different dinosaurs dying, he was clarifying his question. How did they all, that very first stage, so they died, but they're in what was possibly becoming a really dry place. So were they covered over by something quickly for that fossilization to start?
They may have laid out on the surface. Some of the bones are partially eroded when we find them, and some of them are really, really well preserved, where all the surface of the bone is still intact. So it could have been a muddy spot where they, a lot of times preservation in mud is very good. A lot of the bones that are in the mud layers here are much better preserved than the bones that are kind of like in this mashy layer that has little concretions in it of calcite and stuff like that. The bones are still preserved, but not nearly as well.
Is this the best place to find dinosaurs? In the USA, where you're at?
In the U.S., Utah is definitely a really good place to find dinosaurs. For one of those reasons is because it's desert-like and there's not a lot of vegetation, and so you can find them. But also because it's the rocks are of the right age to find them. The exposed rocks are within that time period when dinosaurs lived. They first evolved about 230 million years ago, and then went extinct mostly 65 million years ago. And that's about the age of the rocks here. But you can go to Montana, North Dakota, South Dakota, Wyoming. Dinosaurs and fossils have been found on every single continent in the world, including Antarctica. And so you really can find them everywhere, but you have to know where to look as far as the rocks go.
Is North Carolina a good place to find dinosaur fossils?
North Carolina does have some bedrock that's the right age, but it's not very well exposed, and it can be hard to access those areas because North Carolina has a lot of private land, and you can't just go on people's private land to look for dinosaurs. But right around Raleigh, there's a lot of rocks that are of Triassic age that we've collected from, and a lot of those specimens are in the museum now. And those are earlier than dinosaurs. Those are kind of like the early ancestors to crocodiles and stuff like that we're finding there that are really cool too.
So if you have questions, first, second, or third floors, you can raise your hand. That way that I know. Sure, go ahead. So there's a question. Will the specimens that you're digging up now, the fossils you're finding now, are they coming back to the museum? What happens with them after you dig them up?
They are all coming back to the museum. We will collect them. We've cataloged them as we collected them. We'll unpack them. There's still rock around a lot of them, and they'll need to be professionally prepared in the lab. And then they'll go into our collections. The land we're collecting on is federal land, and so in our country, things collected on federal land technically belong to every U.S. citizen. And so we're basically holding them in trust for the federal government and taking good care of them and letting them be accessible for other researchers to come and look at them, so that we're sharing our information and knowledge across the border and across the country with other paleontologists.
But they get to stay here with us.
Yes, they do.
Sure, go ahead. Or here's a microphone for you. There we go.
Yeah, I'm Steve, and I've been in the desert, Nevada area. But
Oh, wait, it doesn't sound like that one's working. Just come up this way. You can come up here. I know mine works.
what I really want to know is, how do you get all this bones? You got a big giant gymnasium or something?
We have a big collection area in the basement. It's kind of like a library of fossils, and we have cabinetry to hold them all in drawers, and we catalog everything just like a library so we can look it up and find them again. We are starting to run out of space down there, so we're starting to look at different options on how we can expand. But it is a big space.
We got a big space. Yeah, that is a good question, because we've got a lot more fossils than just what our teams are bringing back at the end of this week, right? We've got, do you know how many fossils are in the collection, Lisa?
I think it's close to 100,000.
So 100,000 elements,
yeah,
pieces of fossil.
That includes fossil vertebrates, fossil invertebrates. We have a lot of clams and shells and fish and, well, fish are vertebrates, but, and then we have paleobotany specimens, so we have some plants and stuff like that, and that includes all of that stuff. One of the problems for us now is that we're collecting dinosaurs, and dinosaurs can be really big and take up a lot of space. You know, you find one dinosaur and your whole collection's full. About 3 weeks ago, we were on a dig in Montana, and we found and uncovered a complete Triceratops skull. And the skull itself, from the back of its frill to the tip of its nose, is 6 feet long. And that's just its skull.
So that's a skull of a dinosaur that is as tall as I am, or as long as I am tall.
Yeah, yeah.
That's a big animal.
Mm-hmm.
So you've got a question. Tell us your name.
Victor.
Hi,
what-
Victor.
What is your question for Lisa?
What's behind you?
What's
There's a
behind
giant
me?
dinosaur behind you.
The quarry is behind me. We've got a team of people working under the tarps. We've got David Button, who's a postdoctoral researcher. We've got Aurora Canaville. We've got Peishu, and then we have Yanelis Delgado. We have a group of total of 5, including me, people working out here.
And so back behind, so that's the quarry under those tents. That's where everybody's down in the dirt, chipping away rocks. What does it look like? What they're doing? What kind of work happens?
Get a little closer. We didn't take the last time we took the tarps down. We didn't do it this time. But
It looks very bright and sunny and hot.
it's really sunny and hot out here, yeah. And I'm standing in the sun, and everybody else is under the tarps in the shade, sitting on the ground, picking and digging up dinosaurs. You got any more questions, Victor?
No.
No? All right.
Thank you very much. It was a very good
I'll see-
question.
Yeah, actually, Victor's my son.
So there's another question. Once you get everything back and you sort of put the dinosaur back together, how big is Falcarius?
Falcarius is about 15 feet from nose to tail and like maybe 3 to 4 feet high. Wasn't a huge dinosaur.
I don't. 15 feet long sounds like a good-sized creature
Yeah,
to me,
but
though.
a lot of that is tail. The tail was long neck ish. Kind of it looked a little bit like a T-Rex, a mini T-Rex, but
Like a really small T-Rex.
yeah, it just walked on 2 legs like a theropod does.
So if you're here with me in the theater, 15 feet from nose to tail would be about the entire width of the stage. So, and I'm, about this tall, so I mean, I would have run from it if it chased me.
Yeah. Its teeth weren't very big though. We actually found a dentary in its lower jaw, part of its lower jaw yesterday. We were really excited. It's the first bone of that type that we found, and its teeth are actually pretty small. I don't think I'd be afraid of it.
You wouldn't be, okay, maybe it's just me then. So I missed the first part of that, though. We lost the audio for a second. But so you were describing something else about the teeth.
The teeth? Oh, the teeth aren't very big, is what I was saying.
Okay, that was, okay.
We found a piece of its lower jaw, and it's really rare to find skull elements in the quarry because they're thin and fragile, so they don't preserve very well. But if you find one, it's pretty exciting. And we found part of a dentary that had some teeth in it. And the teeth are pretty small. They're like smaller than my pinky finger.
Yeah, that doesn't sound too bad.
Yeah.
Not that I have to worry about them nowadays anyway.
No, just chickens. Watch out for those chickens.
Chickens are dinosaurs. Yeah, I often tell people think maybe dinosaurs weren't that scary, but if you've ever been chased by a chicken, dinosaurs are actually pretty terrifying. So I'm going to look around. Any other questions for Lisa from down here? If you have questions, you can come up. Sure, come on up. I think you know each other.
Did we? Oh yeah, that's right.
I don't.
Yeah, something happened like 14 years ago. We got married. That's what happened. Yeah. Well, you said something about this Falcarius being a therizinosaur. Is that correct?
Yeah. Yes.
Do they have the long fingernails or whatever that I'm familiar with from Dinosaur Train?
Yes, from Dinosaur Train. So the therizinosaur that you're thinking of is from Mongolia.
Okay.
So there's therizinosaurs from Mongolia, and their finger claws are about 4 feet long. We have some cast replicas of them in the lab. They're huge. But the ones here are about, the biggest one we found is maybe 4 inches long.
Okay.
They're not nearly as big.
Okay. Cool.
Or scary.
Thank you very much.
You're You're welcome. See you in a couple of days.
So we have like wimpy therizinosaurs in North America.
Well, I don't know if I'd say wimpy, but not as big a claw as the ones from Mongolia. These were really early therizinosaurs when they first evolved, and then their claws got a lot bigger. Apparently, I don't know.
You said it had a 4-foot long claw.
Yeah, just the claw is about 4 feet long. We have some casts in the lab, but I don't think they're on display. And the part of the, you know, your fingernail is made out of keratin. It's a sheath. Dinosaurs and birds, their talons and everything, they have a sheath on top of it. So the only part that actually fossilizes is the bone part. So when we find a claw, that's just the bone part. It would have had keratin on it that would have made it even longer by maybe 10 or 15%.
That's incredible stuff. I've been fortunate enough, I have seen at least the cast that is up in the paleontology research lab, which for everybody here, it's up on the 3rd floor of this building. So you can head up there and you can look through the windows of the Paleo Lab and see some of the recently collected material from earlier expeditions this year and from years past. And you can see where our experts are chipping away rock and trying to get at that all-important dinosaur fossil bone. So for the stuff that you're bringing back from Utah in just a couple of days, how long do you think it'll take to process it and, you know, sort of put it together back into a Falcarius and start doing some science?
It'll take a long time. Just unpacking it's going to take a while because we've got 270 specimens. And a lot of the work will be done by volunteers. And, you know, putting it together, I don't know, it'll take a couple of years probably. And we'll come back here and collect more too. And it depends on if anybody's going to study it.
So we'll have it here for a scientist, paleontologist who does want to study it.
Yeah. Things that are actually getting researched get priority because we have a backlog right now.
We've got more fossils than we know what to do with.
A little bit. We know what to do with them.
We know what to do with them.
We need more time to do it in. More staff.
Do you know how many active research projects there are with our fossil material?
Inside the museum or just anywhere? I mean,
yeah,
there's a lot.
Inside the museum. In
the museum, we've got 4 graduate students, 2 postdocs, Lindsay, you know, a couple other undergrads and stuff like that. There's got to be at least 15 or 20 different projects going on simultaneously. Maybe even more. It's hard to keep track.
So, folks, to remind you what we've got going on, if you're just joining us, Lisa Herzog works in the Paleontology Research Lab here at the Museum of Natural Sciences up on the 3rd floor. But right now, she is out in Utah working in a dinosaur quarry, digging up fossils of a dinosaur species called Falcarius. So if you have any questions about anything dino-related or the work that's going on here at the museum or out in Utah, you can raise your hands, and I can use the microphone to ask the question. So if you're up on the 2nd or 3rd floors and you've got questions, I can see you pretty well. You can just raise your hands, and we can use the mic, and you can talk to Lisa. Learn a little bit more about dino paleontology. Will the public get to see any of the Falcarius?
Yeah, because if you go up to our lab upstairs, we'll be processing all the specimens in the lab, and you can watch us process them, prepare them as we go through all of them and get them organized and stuff. All the research and everything goes on in that lab. So if you want to see what's happening in paleo at the museum, you need to go up to the lab and just kind of look and see what's happening in there. We try to put up signage and sometimes come out and talk to people about our projects and stuff like that.
All right. Any other questions? 2nd floor, 3rd floor, down here. Well, Lisa, I know it's hot. I know it's sunny. Thank you
Yeah,
so
we got
much for calling in.
closed down. Oh, thank you. It's good to
And
see
you said
everybody.
this is your last day, right?
This is our last day, so I got to get down in there and we got to collect the last few things and bury the quarry in and close it down, pack up camp. We got to drive for 2 days to get home. It's really far. Um, so we're kind of pushing the limits for time here.
Well, I'm gonna.
Yeah.
Yeah,
Oh, that's fine.
I had a
Question?
last-minute question jump in.
Uh,
Tell us your name.
Samira, have you found any eggs or like dinosaurs that are young or anything like that?
Some of the stuff we're pulling out of this quarry are kind of like babies. The bones are really tiny and small. We haven't found any eggs or eggshell, but the other team that's out in Utah right now, they're about 120 miles straight behind me. They were working an egg nest site, and they found a whole bunch of eggs all in one area, which is really cool. They're the plaster field jacket, the specimen that they're trying to collect is too big to bring back, and they plaster capped it and buried it, and we're gonna have to get a helicopter to get it out because it's such a big concentration of eggs. It's really cool.
So they're gonna helicopter out an entire dinosaur nest.
Hopefully.
Hopefully.
Fun.
Wow, that's really cool.
Yeah.
Well, everybody, looks like there's something to look forward to. We're going to have Falcarius dinosaurs back here at the museum soon, and maybe one day you'll also get to see a dinosaur nest of eggs.
Yeah, and we're
stuff.
also looking forward to getting that Triceratops skull back here, too. We need a helicopter for that one, too.
Yeah, I think that's the one I'm most excited about.
Yeah, me too. Although
Right.
the eggs are full.
I mean, it really all is amazing, incredible stuff. And that we can know about the world from 120 million years ago by going out and digging around in the dirt for 2 weeks.
Yeah, and a lot
Plus-
of people
plus
think
years.
everything's already been discovered, but we're finding out new things all the time.
All right, well, Lisa, we'll let you go.
Okay.
Thank you very much. Everybody say bye, Lisa.
Bye, everybody. Thanks for stopping by.
And thanks to all of you for coming to the museum today and with us, with our paleontology research team, all the way out in Utah. You can follow the paleontology team at expeditionlive.org, I believe is their blog, where you can see photos and things that have gone on. You can also follow at Expedition Live on Twitter and the hashtag UT, as in Utah, UT Dino Dig 17, to see everything that's going on with both of the dig teams at both of their sites. Thanks for coming out today, folks. We'll see you again here at the Museum of Natural Sciences. Bye, everybody. Thanks, man. Check, 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 check.